I need to get through this first, and I'll let you go once we start the activity. Alright, so we should have x minus 3 times x plus 2 into the calculator. After you do that, after you type that in, type in that standard form as well. So graph both x minus 3 times x plus 2. So there's that parabola. Thank you, Mar. I'm aware. If you are struggling, please reach out to a friend next to you. Nope. Once again, you gotta put parentheses because we are multiplying. Now type that standard form in. Now type the standard form in. How you gonna do that, Jordan Irby? Oh my gosh, it must be really hard to pick up a calculator. What's the button lets you do cool crap? Thank you. Go graph your standard form. The x squared minus x minus 6.
What?
What? My God, you've got to put parentheses if you're multiplying these two things.
You gotta do the other one now.
Now type in your standard form.
The other equation. What did Bailey crash out? The one with the
Okay.
Menu.
Graph entry slash edit. You're graphing a function. Hit enter. You gonna put graph? Hit enter. Okay. There. Okay. So, guys, we gotta know how to graph functions, but looking up here right now, are they equivalent? Yeah. How do we know they're equivalent?
Because they're in the same place.
They're in the same place, so the same, there's an I word, inputs are mapping to the same outputs, right? They're exactly the same function, the same inputs are mapping to the same exact outputs. So yes, those are equivalent. Guys, you need to know that foundational piece here. So determining if a polynomial in standard form and in factor form are equivalent. And legitimately, I need y'all to hear me on this, if you can have conversations about things, then I can mark off proficiency. Literally, Jaden Gladden, 3 weeks ago, right before the midterm, was explaining in class how, hey, look, we could just go graph these two functions and see if they're equivalent. Based on his conversation, I was able to go and mark off proficiency on his proficiency scale.
What class just did?
Huh?
What period just did?
First block.
Of course.
Oh, of course. You mean he learned something, right? Yeah.
The first block, man.
They try to learn. I know, it's wild.
Yeah, man.
Listen.
Don't.
My point is that if you explain something, if you learn something, proficiency can be marked off.
That Patrick.
That's it. Show me proficiency. Now, what we are trying to get into here is sketching polynomials when given the graphs of their factors. And so I'm going to explain what this means in a little bit, but here's x squared minus x minus 6, right? What is one of the factors for x squared minus x minus 6?
Excuse me?
What is one of the factors for x squared minus x minus 6? Well, what do we do with factors? Oh, we multiply factors, right? And we already said that this standard form and this factored form are equivalent, so what's one of the factors for x squared minus x minus 6? What do we do with factors? Okay, so I have my factored form here. What's something I'm multiplying by?
Oh, wait. X. X minus 3.
Isn't x minus 3 being multiplied?
Yeah, by x plus 2.
By x. Oh, so what's the other factor?
X plus 2.
Oh. Guys, that's the whole point of the zero products property. The only way to get a product of 0 is if at least one of the factors was 0. That's it. There's my factors. So what we're looking at is being able to sketch a polynomial when just given the graphs of the factors. Sketching polynomials when given the factored form of the polynomial, or when asked to dilate a polynomial by a new factor. And so the rest of these things all naturally come out of that. How did I already set down? There it is. Now, apparently I updated things, so I'm glad of that. Here, we're going to be getting into some features of these functions, like domain, range, intercepts. Hopefully we recognize that term, domain and range. Does that sound familiar from Algebra 1? Kyle's giving me a looks like no, I've never seen that.
It's the one that you did with the parentheses and the
Brackets?
yeah.
Yeah. But we don't fully remember what domain and range are? Okay. We have to talk about that as a class. I'll go ahead and give you a slight reminder. Domain is all of your x values or inputs. Oh no, that doesn't even sound familiar? Casey's saying yes, it sounds familiar.
Range on the right side.
Say again.
Huh?
What'd you say?
Domain on the left side, range on the right side.
Not quite. So remember what I just said, domain is all of my x values, right? So left and right is where I find my domain. Range is all of my y values, which is up and down. So we're going to talk more about that, I see. But I apparently already added these vocabulary terms in, so you don't have to write those. We're going to talk about degree a whole lot more. By the way, I do want to remind you, a quadratic function, what degree was a quadratic?
2.
Degree 2. What degree is a linear function?
1.
The understood exponent is a 1. So we're going to be looking a lot at degrees of these functions to understand them better. Alright, here's where we actually have to start in Desmos. Nope, that's not it. So here's the Desmos activity. Go ahead and get up, move to your groups while this is loading, and then we're going to talk about the first little part of this activity. Yes, go quickly. Who else asked? Casey. Oh, because you're taking and then yes, you can go to that as well. And you need to go get your marker. Alright.
You see on the right side of the board? The bottom right.
Okay. If you have to, we'll have you working in a different group. Alright, right here. So, did I mention the white books in this class yet?
The what?
You see the vertical surfaces that are white books? It says at the top.
Yeah.
Please do not touch those. They are set up for my first block, and we'll be using them all day tomorrow. That's why they're still up. You may use the TV, all the other vertical surfaces. Just do not write on or erase the white books. Okay, from there, Jacob, you can scoot to the side for me, please. So when I look at this right here, I have two functions graphed. I have f of x, a red line, and I've got g of x, a purple line, and I've got a value of a here and a value of b, so that those can change things about the line. What I want you to do is I just want you to change each constant value one at a time. So a is a constant, it's equal to 1 right now, and I can change it, but that is a constant. B is currently 0, but I can change it. And what I want you to do for each value is figure out or come up with a conjecture about how the purple function differs from the red function. So how do those values change the purple function? If you remember your transformations, try using that language. If you don't remember transformations at all, we'll talk more about it after this slide. So I'm giving you 2 minutes. I just need you to look at one iPad altogether, play around with your A and your B, and figure out what you think that A and B are doing. Notice, you don't have to have a lot to be successful. Just what do you think is happening? That's all I'm asking. We will talk about it in 2 minutes.
What?
See, senor. Oh, what? We're working on it?
You can pass as a little kid.
Please bring your device to administrators.
Let me take the library.
I want free candy.
So whenever you're looking at this iPad with Caleb,
I'm okay with that.
trying to think of
And it's not.
Are you cool?
Oh, you yeah.
You're too old for this. Slider and talk about what you do. We've got 40 more seconds until we start talking about it. Here's my calculator on the ground. Feeling me.
I put it there because I had to get up to go look at what she was doing.
How could you describe that? What's happening there?
Rotates it 160 degrees.
Can rotate it, yeah. That sounds like familiar
I got concrete
transformations
and
that you studied in geometry.
I got concrete and a cut in my
That's
finger.
not ideal.
Geometry 2 years ago.
I know, but that's all it's you.
That's not
With Desmos? Like with an email address?
What?
Just log in again. It's gonna bring it up.
That's a nice
Come on, Ladarian. You could not be bored if you actually got a Death Star with Charlie. Kristen, can you what math y'all talking about so far?
I bet it.
Hey, Tristan, there's people all around this room who have an iPad. They'll find someone to talk about the math. You're trying to give me a reason that you haven't done the thing you're supposed to do. All right. You already logged in though, didn't you?
Give me some. Because you push your head.
It's weird. I know you already have some of that email address.
Like, I want to do it.
You could. 100%
Yeah.
What was it?
The brony?
Yes.
That ain't mine. Who did it?
You know what?
Oh,
Why
I'm
would you
all
want?
right,
Why would you want you?
Hey, Gary.
Let's engage in conversation. All right. Sorry, Kyla's iPad's stressing out. So, how do I have 4 aces? How's that happen?
You don't got no car. This the road is straight in.
I gave out 3 aces. I did not give out 4 aces. All right, so let's talk about this, about the math, about what's happening out here. So, when I look at A, Lillian, don't say anything yet. What did y'all notice about A? What's a way to describe what is happening with A? It's moving. How is it moving though?
3 C's.
Hey Rose, I need you engaging this conversation instead of messing with the whiteboard. Thank you. So what's A doing?
Moving around the full circle.
Okay, so
Increasing.
and decreasing. Now be careful, mathematically, when we say increase or decrease, we mean that we're adding and we're subtracting. There's something happening there, but I want to point this out. If you look at this equation from here, am I adding or subtracting that A? No, what's happening with that A? It's being, so hold on to that idea, right? So Lillian, what was the word you used to describe what was happening?
Rotate.
Rotating, right? Like, look at that line. Is it rotating around? Yeah, 100%. That line is being rotated. All right? So we have a rotation there. Now, there's something else I will point out, and I want you to notice this. Okay? When I look right here, what is the y value associated with this point? What's that y value? What is it? 1. What is this y value? Okay, so 1 became 2. Can someone please let Christina in? What is this y value? And what did it become? 4. What is this y value? Sorry, this one. I was pointing at 3, and it became. So we went from 1 to 2, 2 to 4, and 3 to 6. What's happening there?
Multiplied by 2.
Being multiplied by 2, right? What's happening right here? It's being multiplied by 2. So, what is that called when something is made bigger like that? Because it's not been moved, it's been stretched almost. It's a what? It's a dilation. Anyone who ever has gone to the eye doctor, what did they do to your eye when you were there? They dilated it, right? They made your pupil bigger so that more light could get in, so they could see into your eye more easily. It's being dilated. When things are made larger or smaller, they are being dilated. I need you to hold on to that. Okay, so we're dilating there with that A. What is B doing to this function? It's moving it up and down. Does anyone remember a transformation word for moving? It's being moved up or down? No one remembers the transformation word for moving up and down?
Isolated.
Good question. Good thought. Say it again. Say it louder. Transition. You're super, super close. Say it louder, Kyle. Translation. Huh. So when we move things up and down, it's called a. Hey guys.
Translation.
Translate means to move. So things are being translated here. Now I need us to look at the next slide. So let's look at n and o really quickly. So you'll notice I again have y equals x squared here. I now have f of x equals m times x minus n squared plus o. We're going to look at n first. What is n doing to that parabola?
Translating.
Is it moving it or translating it again?
Yeah.
I'm glad I got at least 2 people who are seeing that translation. What about O? What is it doing?
Translating.
It's moving it up and down, isn't it? Okay, now I want to point something out really quickly. I need you to pay attention to this. What was the translation? What caused the translation here? Can you hit the lights for me real quick, Gio? What was causing the translation here in this equation? The what? Which value? The A or the B?
B.
The B. What mathematical operation is there with that B? It is being
Added.
It's being added. When I look over here, what's happening with the N and the O? Because that was what was causing the translation as well. What's the operation with the N and the O? It's being subtracted and added. So remember the square right here, that's part of the defining the function. But what I'm talking about is the N and the O. We're adding and we are subtracting. But remember, subtraction is a type of addition. AJ, I'm glad you're really impressed by those blocks, but I need you involved in this. Okay. So, what does addition and subtraction always cause? It causes a translation. So, whenever we are adding or we are subtracting, that is causing a translation. But what is happening with this m here? In the equation, wherever my cursor went, there it is. In the equation, what's happening with m? Is it being added or subtracted? It's being multiplied. Alright, so I'm going to get this back to the original starting point. Thrasher, I know you're not talking about math, are you?
Oh, yeah. Yeah.
So let's fix that. So what is m doing? What is that multiplication doing? Is it translating it at all? No? It's dilating. Notice it's vertically stretching it. Right here was 1, 1. Now it became 1, 3. It was multiplying by a value of 3. What about if I make m a negative? What's going to happen?
Decrease.
Look at it. What happened? Why was it up and now it's down? Because it was not rotated, not dilated, not translated. There's another R word. You can see it this way.
It was reflected.
I heard someone say it. It was reflected. Okay? So, what I need y'all to hear on with this is, hey, chill, I'll put it through. You got plenty of time to pack and backpack. Oh gosh, I'm so sorry. I forgot I said, pack up and move around the room. Or I said the opposite of that.
Oh, I ain't even said it.
Right here. Listen, what is addition and subtraction doing? What operation? Or what transformation? Translating. What is that multiplication doing? Dilating, right? And also it can cause a reflection. Now here's what I want you to hear me on. When we did those transformations, it changed the function, sure. But did it keep it the same type of function? Or did it change the type of function? Look at that red. What type of function is that? Guys, what type of function is that in red?
Quadrant.
Quadratic. That's a parabola, right? What type of function do I have in purple?
Quadrant.
Also a quadratic. So what we're getting into tomorrow is, what about this? What if we transform a function by a variable? So we transformed by 2 and by 3 and by 4 and -1 and -2 and -3. But what if we start to transform by a variable? What is that going to do? And that's where we'll pick back up tomorrow. Don't forget your iPads. Someone's leaving theirs on the whiteboard over there.
It's just.
It's whose? Geo's. Cool.